Hope you are all fine. Today we will start with first chapter of unit 1, that is carbohydrates. Carbohydrates, they are synthesized by green cells of algae plants and many protists by the process of photosynthesis, in which they take up chlorophyll and sunlight. In presence of chlorophyll and sunlight, they manufacture carbohydrates. Common examples of carbohydrates are sugar, starch, glycogen and cellulose. Carbohydrates, they are composed of carbon, hydrogen and oxygen. Generally, carbohydrates contain hydrogen and oxygen in the ratio 2:1. That's why they are also known as hydrates of carbon. We also call carbohydrates as saccharides, and their general formula is CnH2nOn. Chemically, carbohydrates contain many hydroxyl groups and carbonyl group. So we call them as polyhydroxyaldehydes or polyhydroxyketones. So they contain many hydroxyl groups plus they contain carbonyl group. If carbonyl group is present at the end, it forms aldehyde group. If carbonyl group is located in the middle of the carbon chain, then it is the ketone group. It will be clear to you when we will study an example. It means carbohydrates, they have many hydroxyl groups plus they have aldehyde or ketone group. So carbohydrates which have aldehyde group are known as aldoses. Example is glucose and galactose. Carbohydrates which have ketone group, they are known as ketoses. Example is fructose. Carbohydrates, they are classified into three categories: monosaccharides, oligosaccharides and polysaccharides. Monosaccharides, these are the simplest carbohydrates which cannot be broken into smaller carbohydrates. Oligo and poly, they are formed of monosaccharides. In oligosaccharides, there are 2 to 6 monosaccharide units which combine. In polysaccharides, there are more than 6 monosaccharide units. So first of all, we will take up monosaccharides. So these are the simplest carbohydrates which cannot be broken into simpler carbohydrates. Their general formula is CnH2nOn. So they contain 3 to 7 carbons. It means the value of N varies from 3 to 7. And on this basis, monosaccharides, they are classified into different categories. First category is triose. Here the value of N is equal to 3. So naturally general formula becomes C3H6O3. Example is glyceraldehyde and dihydroxyacetone. Both of them, they are produced as intermediates in metabolism, that is energy releasing process, and photosynthesis. Second category is tetrose. Here N is equal to 4. So general formula is C4H8O4. Example is erythrose. It is also produced as an intermediate in energy releasing process and photosynthesis. Then pentoses, N is equal to 5. Molecular formula is C5H10O5. Example is ribose and deoxyribose. So here just see, ribose has molecular formula C5H10O5. Deoxy means one oxygen less than ribose. So it becomes C5H10O4. So just compare it. This is the molecular formula for ribose sugar. Deoxyribose means one oxygen less. So this is the molecular formula for deoxyribose sugar. Ribose is the component of RNA, deoxyribose is the component of DNA, ATP. Then besides this, they are present in some coenzymes also that we will take up later on. Hexose sugar, here the number of carbon atom is 6, so N is equal to 6. So molecular formula becomes C6H12O6. Examples are glucose, fructose, galactose. Here glucose is the main source of energy or fuel. Now haptoses, they contain 7 carbons. So molecular formula is C7H14O7. Example is C2-heptulose. It is also produced as an intermediate in photosynthesis and energy releasing process. So if you sum up, triose, tetrose and haptoses, they are produced as intermediates in photosynthesis and energy releasing processes, whereas pentose contain ribose and deoxyribose sugar. Hexose, they contain glucose, fructose and galactose, which are the main source of fuel. Now an important term, what are isomers? Isomers, these are the compounds which have same molecular formula but different arrangement of atoms. So we call them as isomers. Example is glucose, fructose, galactose. Here just see, all glucose, fructose and galactose, they have same molecular formula which is C6H12O6, but they differ in arrangement of atoms. So this is the structural formula for glucose. It has aldehyde group at the end, so it is known as aldose. So this is carbon atom 1, 2, hydrogen on this side, OH group on this side, OH, H, H, OH, H, OH, H, OH, CH2OH. So whereas in galactose, remaining structure is same. Glucose and galactose, they only differ in position 4. At 4th carbon, hydrogen is on this side, OH group is on this side. Whereas in galactose, OH group is on this side, hydrogen is on this side. Whereas fructose have ketone group. So this is the ketone group. In the beginning I have told you, if carbonyl group is present at the end, then we say it is aldehyde group. If carbonyl group is present in the middle of the carbon chain, we say it is a ketone group. So here it has ketone group, and this is the position of carbon atoms 1, 2, 3, 4, 5 and 6. So these 3 molecules, they differ only in arrangement of atoms, whereas their molecular formula is same, that is C6H12O6. These are known as isomers. What are the properties of monosaccharides? They are sweet to taste, they readily dissolve in water, but in solution they occur in 2 forms. These are open chain form and ring form. So the structure that we have studied over here, these are open chain forms. So ring forms, they are of 2 types, pyranose ring, furanose ring. Pyranose ring is hexagonal, it has 5 carbon atoms and 1 oxygen atom. So how pyranose ring is formed? Here I have shown you, this is the open chain formula for glucose. Simply interact carbon atom 1 with carbon atom 5. Now from this OH group, shift hydrogen to this oxygen and bring this oxygen in the middle. So just see, this open chain becomes like this. Now simply convert it into ring form. This is the position of oxygen. This is carbon atom 1. So at carbon atom 1, all the groups which are present on the left side, place them on the upper side. Groups on the right, place them on the lower side. So जिन्ने भी ग्रुप इधरली साइड ने उन्होंने असी ऊपर रखना वा, जेडे ग्रुप इधरली साइड ने उन्होंने असी नीचे रखना. So just see, this is carbon atom 1. Hydrogen on upper side, OH group on lower side. Carbon atom 2, hydrogen on upper side, OH group on lower side. Carbon atom 3, OH group on upper side, hydrogen on lower side. Carbon atom 4, hydrogen on upper side, OH group on lower side. Carbon atom 5, hydrogen and then CH2OH. So this is the pyranose ring of glucose, which is formed by interacting carbon atom 1 and carbon atom 5 of open chain form. Then comes furanose ring. Furanose ring is formed, again this is the open chain formula for glucose. Simply interact aldehyde group with OH group at position number 4. Pyranose ਦੇ ਵਿੱਚ ਆਪਾਂ 5th carbon ਤੇ interact ਕੀਤਾ ਸੀ. Now we are interacting at position number 4. Likewise, shift this hydrogen to this position and bring this oxygen in the middle. Now convert it into ring formula. This is carbon atom 1, so O ring HOH, HOH, then OHH, then CH, then CHOH and CH2OH. So this is furanose ring, which is pentagonal, having 1 oxygen atom and 4 carbons. So this is how open chain form is converted into furanose ring.